Welcome to True Projects. In this video, we are going to explain about the project that is PBVIT, a patch-based vision transformers for enhanced brain tumor detection. So before getting into the execution, first let us understand what is the project about. Brain tumors. They are serious health problems because they happen when the cells in the brain start growing uncontrollably. And this abnormal growth interferes with the cells that is brain's normal functions. And there are three main types of brain tumors. One is glioma, other one is meningioma, and the last one is pituitary tumors. So coming to this gliomas are the most aggressive since they are malignant and they can spread quickly. They are dangerous. Coming to meningiomas are generally not cancerous but can still cause serious neurological problems by pressing on the brain or spinal cord. Last type of tumor, that is pituitary tumor, they are usually aren't malignant. But because the pituitary gland controls important hormones, these tumors can cause significant hormonal imbalances in the body. So early detection, that is detecting brain tumors early and accurately is really important because it allows doctors to start treatment sooner. This improves outcomes and can even save lives. Doctors typically use images like MRI, that is magnetic resonance imaging, and CT scans to look for tumors without needing to do surgery. However, interpreting these images requires a lot of expertise, and even specialists can sometimes make mistakes, especially if the tumor is small or in a tricky location. On the other hand, procedures like biopsies, which involve taking a tissue sample, are invasive and come with their own risks like infections or accidental damage to nearby brain tissue. So, here where machine learning comes into the picture. In recent years, that is machine learning and especially convolutional neural network models, have become very popular for analyzing medical images because these models are really good at recognizing patterns and detailing in the images. For example, they can detect subtle differences in MRI scans that might indicate a tumor. Here, there is a problem that CNNs have some limitation. They can struggle when tumors have irregular or unusual shapes, or when there are features in the image data that are spread out across the brain rather than being in one small area. They also need a lot of label data to learn properly, which can be hard to collect in medical settings. Training these models can also take a lot of computing power, which makes it challenging to use them for a quick, real time diagnosis in hospitals. Because of these challenges, there is a strong need for automated and accurate detection methods that can help doctors find tumors earlier, reduce the need for risky procedures like biopsies, and improve overall patient care. So, here the main goal of this project is to create a system that can accurately detect and also classify brain tumors from MRI scans. So, to do this, this project uses a special type of machine learning model called patch based vision transformer, that is PBVIT. This model works by breaking the MRI image into smaller pieces or patches and treating them, that is, treating each piece like a token that the model can analyze. So, the model it uses a mechanism called self attention to look at all the patches at once, which helps to understand not just the small details in each patch, but also how the patches relate to each other across the whole image. By adding positional information, the system knows where each patch is located in the brain. This helps to identify exactly what the tumor is. This approach allows for classification of tumors, improving reliability and diagnosis. And the system overcomes some of the main problems that traditional CNN based models face. For example, CNNs often struggle when tumors have irregular shapes, when there isn't enough label data to train the model, or when computational resources are limited. The proposed system solves these issues by using a transformer based model that processes the MRI image into small patches, while also looking at different relationship between all patches. This approach helps the system to extract features more effectively and identify tumor boundaries more clearly and make accurate predictions. So, to further improve the performance of this project, for classification, we have incorporated exception and inception models to analyze the brain tumor dataset more thoroughly. These models helps the system to extract important features from MRI images and improve classification performance. And also coming to the detection module, here we have used YOLO models, which allows the system to not only classify the type of tumor but also pinpoint its exact location in the MRI scans. To make the model's decision more understandable and explainable, here we have used GradCam, which is an explainable AI technique. To create heat maps, GradCam has been used, which shows which parts of the image were most important for the prediction. And also, to develop a user interface, we have used Flash framework that so that users can easily upload MRI images and get predictions from the trained model. This makes the system more interactive and also user friendly, allowing it to be used practically in real world settings. So this is the prototype. So this is a demo piece where application, that is users, they will be able to use the application and upload images and they get predictions of the brain tumor. Moving on to implementation. To implement this project, we have followed steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First, we have imported all the necessary libraries, that are Python libraries and frameworks that are required for data processing and model building and also evaluation. Then coming to the dataset preparation. So here we first collect the MRI tumor dataset, and for classification we ensure that all the labels are assigned for the specific image. And for detection, we draw bounding box annotations that are created in the YOLO format to mark the exact tumor regions. And the dataset is then split into trained, validation, and test sets to prepare for the model training. Then comes visualization. So here in this part, the distribution of tumor types in the dataset is displayed using bar graphs. Sample labeled images are shown to verify that the labels and bounding boxes are correct. Then coming to pre-processing. So here we will be resizing the images. That is, images are resized, normalized, and augmented to improve model training. Then comes data augmentation. So here it is applied to increase the diversity of the data. Then a data.yml file is created for the YOLO containing paths to images and class names. And then we will be maintaining classification images and YOLO images. That is, we will be maintaining two separate set of images for classification task and for YOLO task accordingly. Then we will be training all the machine learning models. That is, all the models for classification as well for detection. So for classification, we will be using PBVit, DeepCNN, and exception inception. And for detection, these are the models. And we will be evaluating all of those models using their respective metrics. For classification, we will be using these metrics, and for detection, we will be using these metrics. And we will be comparing and select the best performing model for the future use. So coming to the inference pipeline. So here, images will be given as the input, and then application will be predicting, that is, the code will be predicting the tumor type. And coming to the front end, here we have developed a Flask-based web frontend with a registration and login functionality supported by an SQLite database. And users in the frontend, they will be able to provide images for detection as well as for classification. If you want detection, you can consider with the detection. If you want classification, you can just upload image for detection. And that image will be pre-processed at the backend. It will be fed to the trained model, and then trained model will be giving us the prediction. So moving on to the algorithms used, these are the algorithms used in this project. For classification, these are the models used, and for detection, these are the models used. And to implement this project, basically we need two types of requirements, that are hardware and software. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB, and hard disk of 25 GB. And software are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4, and databases SQLite 3. So this is the overview. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. So these are the source code files of this project. Let's understand each of them. How will they be used in this project? Here in this folder, we have the dataset that is used. Let's open it. Here we have 4 different types of tumors, right? That is glioma. Let's open glioma folder. Here we have MRI images of the glioma tumor. Similarly, we have images of meningioma tumor. These are the images of meningioma tumor. And these are the images of no tumor. And these are the images of pituitary tumor. So all these images, they are splitted into train and validation in the output folder. Accordingly, we will be having a train folder and also validation folder. So this train folder will be used to train the model and validation folder will be used for evaluation. So the images which are in this folder are used for training classification models. And in this model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. And this is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here in the templates folder, this folder consists of files related to HTML pages. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the test cases folder. Let's open it. So here we have images for classification and detection. These we will be using in the front end for detection. And we have images in the YOLO folder also. Let's open it. Here we have images in train and valid. Let's open images which are in train. And here we have in two folders. That is, we have images in image folder and tumor locations in this label folder. So let's open images folder first. Here we have clubbed all the meningioma, glioma, pituitary and no tumor images into one subfolder. Get back. And we have tumor locations in this label folder. That is boundary box coordinates in this label folder. So this label folder, I mean, these files are the annotation files we call it as, or else we call it as label files. So each label file, it corresponds to an image file in the image folder. For example, the first image file, it contains, I mean, it is corresponding to the first image file. And for the second image, we have second label file, which contains, I mean, which provides details about object locations and classes within the image. That is, it provides locations of the tumor and classes of the image. So all these label files are of corresponding to the images folder. And these label files, they follow the YOLO format. Get back. And we use this validation folder for evaluating the YOLO models. Get back. So images which are in this folder will be used for detection task. And coming to this app.py file, this .py file, it contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two Jupyter Notebook files. So these files, in that we have code written that is also a combination of code. We have combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, which makes it a popular choice for the data science. And code which is written in this folder is for training classification models on this data set. And code, I mean, this Jupyter Notebook file, we will be loading this data set and we will be writing code and training the models for detecting YOLO models. And this is the signup.db file. This file is a database file which is used to store the user information. This is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying it. So now open Anaconda prompt. It is open. Give the command cd, give the space, and now paste the copied path. Click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So this is the local host and this is the port. Copy this local link provided by the Flask framework and paste it in any web browser. I have copied the link. I prefer Google Chrome, so I will paste it in that. Paste the link here and now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So now get registered, click on register and enter all the credentials if you are registering newly. I mean, enter all the details if you are registering newly. I have already registered, so I'll directly sign in. Click on login, give your username and the password. So give correct credentials, click on login. We have logged in successfully and redirected to classification page of this project. Now if we click on try classification, we will be redirected to this page. Now click on choose file, open test cases. As we're doing classification, open classification folder. So let's check with the glioma folder. So now let's try with this image. Click on upload and classify. So this image will be classifying. Now click on upload and classify. This image, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us a prediction. So just wait for a while. So here we got the prediction. It is predicting to be glioma with the 99% confidence, that is model confidence. And this is the uploaded image. And here we have GradCam visualization. So this image, it highlights the region of the MRI image that model considers most important for its prediction. Here you can observe red and yellow color, right? So this area show the high influence, indicating where the model focused to classify the tumor to be glioma. It helps us to validate the model and supports medical interpretation. Now let's try with another image. Click on try classification, click on choose file. Now get back, open this folder, select any image of your choice. I'll select this one and now click on upload and classify. So this we will be uploading. Click on this upload and classify. Here we got the prediction. It is predicting meningioma with a 100% confidence. And this is the uploaded image and here we have GradCam visualization. So this is the area where it is focusing for classifying meningioma. Now let's try with some more images. Click on choose file, get back, open no tumor, select any image of your choice, and now click on upload and classify. So here we got the prediction that there is no tumor and here we have 100% model confidence. Image, this is the uploaded image and here we have GradCam visualization image. Now let's upload last image for the classification task. So get back, open the last folder, pituitary. Let's upload this one. Click on upload and classify. So here we got the detection that it is pituitary and here we have 99.97% model confidence. This is the uploaded image and here we have GradCam visualization image. Now let's do detection task. Now click on detection. As of now, when we did classification, it was just telling which type of tumor it is. Now we will be pinpointing, that is we will be locating where the tumor is. Click on try detection. Click on choose file. Get back. Open detection. Select any image and now click on upload and detect. So here is the image and here we have detection in blue color bounding box. So this is the area where glioma is present. It is localizing this area. I mean here, if you observe from this image, this is the area where tumor is present in the brain. Now let's try another. Click on try detection. Click on choose file. Now let's check with this one. Click on upload and detect. Here you can observe this is the area where meningioma tumor is present. It is the abnormal region where application is drawing a bounding box around it and it is classifying it as meningioma brain tumor. Now let's try with some more. Click on choose file. So now let's try with this one. Click on upload and detect. And here you can observe meningioma tumor has been detected. You can observe meningioma tumor is detected. Let's try with one more. Click on choose file. And now let's upload this one. Click on upload and detect. So here there is no tumor. That is why it is drawing a white color bounding box and labeling it as no tumor with a 0.75 probability score. Probability score is nothing but it is the confidence level that how accurate detection is in detecting that particular class. Let's upload the last image. Let's try with this one. Click on upload and detect. So here we have the detection. This is the uploaded image, and this is the area where pituitary tumor is present in the pituitary gland, and it is drawing a bounding box around it, and it is labeling it as pituitary tumor with a 0.84 probability score. So this is how you need to do the detection. Now let's check with the graphs. Click on classification. So this graph shows the sample distribution. Here on x-axis we have all the classes that we will be predicting, and on y-axis we have number of images, that is the count. So these are the images of glioma. That means we have 1621 samples of glioma and 1775 meningioma. Accordingly, we have for no tumor and for pituitary. Now let's check with the number of images after splitting. So here on x-axis we have train and validation, and on y-axis we have number of images. So these many images are used for training and these many images are used for validation. Get back, click on classification, and this is the confusion matrix, and here we have ROC curve graph. This is the accuracy comparison graph. Here on x-axis we have all the models that are trained, and on y-axis we have accuracy. And this is the precision score, and this is the recall score, FN score, and here we have line plot of all the metrics of all models. Here you can observe different colors indicate different models. Blue indicate accuracy, orange indicate FN score, green indicate recall, and red indicate precision. And on here we have models. This is the stacked bar chart of accuracy and FN score. Here this represents accuracy and this represents FN score. And here we have stacked bar of precision and recall. Now let's check for the detection graphs. Click on detection. And here this is the YOLO precision comparison graph. Here on x-axis we have all the models that are trained, and on y-axis we have precision. And this is the YOLO recall score, and this is mean average precision score. Now click on sign out. In this widget, by uploading images to the application it will be predicting what the type of tumor that person has based on MRI image, and it will be classifying. If you want classification, if you want to see where that tumor is, it will also do the detection. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.